So here's the homework. I'm going to show you in a minute what we are going to be doing. I'm going to show you the actual homework so you can see what to be looking for as we go through the lesson. First off, we got to recall, what does this actually equal? This is a key to a lot of your problems for yesterday, today, and tomorrow. Let's see here. So I to the 0 power, or anything to the 0 power, is 1. Anything to the 0 power is 1. That was true way back in pre-algebra and algebra 1. Okay. Anything to the 1 power is that anything. So 2 to the 1 equals 2, 5 to the 1 equals 5, I to the 1 equals I. So the first two here are straightforward algebra rules we've used for a while. Anything to the 0 power equals 1, I to the first power is just itself. And here, yesterday is when we found out I to the second equals -1, and I to the third is 5. Which is just a combination of these two. You take I and -1, you get a negative I. You have 2, you have 1 and 2, 1 to the first power to the second power, you get to the third power. So the fourth one is a combination of 1 and 2. This is very valuable, and I recommend that you wrote this down on your homework as you did these problems repeatedly so that it becomes just automatic. Now let's just look at the homework. Right here. What are we going to be doing now with imaginary numbers? What's going to be new?
Adding and subtracting.
We'll be adding sets of imaginary numbers right here, 34, 35. 36, 37, you'll be subtracting them. And multiplying them. And then dividing them. Okay. And then we do a little bit of solving. The solving, not too much involved. So let me just touch on that first. Notice how these equations don't have any b values. Just a equals 5, c equals 5. There's no like 5x squared minus 2x plus 5. It's just 0 in the middle. When you have it set up this way, you don't actually have to do quite as much work as we're normally used to. You do the old-fashioned way, get the variables on one side, the numbers on the other. 5x squared equals -5. Divide both sides by 5. And you end up with -1. X squared equals -1. Square root both sides. Now here's the catch. When you take the square root of both sides, what do you have to do? So do a plus or a minus. We actually get x squared, x equals plus or minus square root of -1, which equals I. Square root of -1 equals I. So our answer is just plus or minus I. So why the plus or minus? Let's recall. You have this right here. What squared equals 25? And 5 and -5. That's the plus or minus part. So if you take the square root of both sides here, that's why we have to add the plus or minus part. Because 5 squared is 25, but -5 squared is also 25. So that's why we have the plus or minus. Now, whenever you solve these, if you have to do a plus or minus, that means you always get a pair of imaginary answers, which is true in every instance of imaginary answers. They always come in pairs. Because of this, well, to get the imaginary number, you have to take the square root of the negative, And anytime it takes square root of negative, you have to do a plus or a minus. Therefore, it's impossible to just get one answer of plus I or one answer of negative I. Even the quadratic formula problem that we looked at on the board before, it was a 10 plus or minus the square root of negative 47. So if there's always this plus or minus associated with the imaginary answer. So you can do the same process for 43, 44, 45. Okay. I actually those off the homework, so don't worry about those. You're going to be going up to 45 here, and then on the other page you'll be going off. Very similar for these four as well. Next, the rest of the period, I'm just going to talk about here, adding, subtracting, multiplying, that's multiplication, dividing, here's some more multiplying, and then some more dividing. So how can we add, subtract, and multiply, divide? And I'll do an example of each of these. Let's first talk about adding and subtracting. I want you to treat this the same as, what if this was 5 minus 2x and plus 4 plus 4x. So basically, what if there was x's instead of i's? What would you do?
Distribute.
Yeah, you would just add them. There's no distributing. So the 5 and the 4, you get 9. The negative 2x and the positive 4x, you get plus 2x. And that'd be it. You might change it around, say it's 2x plus 4. It's going to be the exact same thing in there. Just treat it like a variable. You have some only other thing, it's kind of a different meaning behind it, but the process is the same. So before we had some numbers and some variables, we said numbers with numbers, variables with variables. Now we're just going to really do real with real and imaginary with imaginary. But the process is the same. The only difference is actually this part right here. With imaginaries, as we saw before, and as it's written right here, you notice how the number is first and then the imaginary part. So we're actually going to write our answer like this, with the real part, the regular number part first, and then the imaginary part second. Normally we always put the variables in the front, like 2x plus 9. On these, we're actually just going to leave it like that. The real part, then the imaginary part. So it's not too bad. Other than that, same old rules, right? So we have negative, on 36, we're just going to be subtracting. So here's where you want to remember to distribute. It's actually going to be minus 9 and minus a negative 3i. So 36 will have 15 plus 3i minus 9 plus 3i. So we have 15 and a minus 9, which is 6. And 3i plus 3i is 6i. Not too bad. The adding, subtracting, as usual, is not too bad. That's as far as we can take. We can't combine, like here, we can't do 2x plus 9 and get 11 something, because they're different types of numbers. Same thing here. This is a real number. This is an imaginary number. We can't add and subtract those at all. Alright. So that's all you really need to know. Just treat it like a variable. Just understand, though, it's why we can't combine them, because of the different types of numbers, different number systems altogether. Alright. So let's go back. Yeah. homework. Let's talk about multiplying. Multiplying, and we'll do several.
For 35, does the i's just cancel out?
Yes, 35, the i's will cancel out, so your answer would just be negative.
Okay.
Same thing in 37, actually. The i's will cancel out. So let's talk about multiplying. Multiplying. Let's go back and do a little review, and then I'll have you do some practice. This is one of those things that's going to seem super easy, but then when you start doing it, there's actually more to it. There's some details that are easy to skip if you're, or easy to miss if you're skipping steps. So, recall, you have 3x plus 2 times maybe 2x minus 4. In order to multiply two binomials together, each of these is a binomial because they each have two terms, there are several methods. There is the FOIL method. Basically tells you to multiply the first terms together in each binomial. These are the first terms, so multiply those together. Multiply the outside terms together, so 3x and negative 4 are on the outside. So multiply those together, 3x times negative 4. The I means inside, multiply those together. And the L meant the last two terms. So basically this told you to do distributive property twice. That's all it says. 3x times 2x, 3x times negative 4, 2 times 2x, and 2 times negative 4. There is also this box method, which some of you learned that is the same thing. It's the same thing, 4 steps. 4 boxes. FOIL has 4 steps, and the box is just 3x plus 2 and 2x minus 4. Of course, these could be interchanged. You can multiply them anyway. But we end up with 4 boxes we need to fill in. Same as the same 4 boxes we have here. 2x times 3x is the first. And then 3x times negative 4, that's the outside. 2x times, that's the inside. And 2 times negative 4, that's the out. So whether you do it with or without the box, just realize you're doing 4 steps, simplify. So we got, let's see here, 2x times 3x plus 6x squared, 3x times negative 4, 2x times 2, and 2 times negative 4. And we always have this diagonal line turned out to be like terms. So we can combine those together. So our final answer was usually whatever this is, that's our A, 6x squared. Then combine these, you end up with, on this one, negative 8x. And here you end up with negative 8. That's how we multiplied binomials together. So we're going to be doing the same process, either FOIL or the box. Which one do you use? The one that gives you the right answer. Don't go with the one that you think is shorter, because it will be faster, but then you get the wrong answer. This works for you every time, and this one doesn't. Use the box. Yes, it's about 3 seconds more writing, but that's worth it. It's a good investment. So let's see what happens when we actually throw in the imaginary numbers to this whole process. That's the next thing. We're going to say, instead of 3x plus 2i, we're going to do like 3x plus 2. We're going to do like a 3 plus 2i. And do the same process just with imaginaries. Let's go ahead and do that. Let's try 3 plus 2i times, let's write this down, 4 plus 3i. And we're going to go ahead and FOIL this out. Distribute property twice. So, yeah, first, 3 times 4 is 12. Outside, 3 times 3i is 29. done. 2i times 4. And 2i times 3i is 6i squared. I times I is I squared. Just like before, the middle terms combined. We have 17i, bring down to 12. Over here, what does I squared equal? -1. I squared equals -1. So this is the new part that we didn't have to do before. Anytime you see that I squared, just like in those homework problems last night, you got to replace it with a -1. So now we have 12 plus 17i, 6 times -1 minus 6, and 12 minus 6 is 6. Once again, I'm writing the real part right here in the front. The imaginary part is always going to be last. So we can throw in some equal signs instead of have some correct form. Take a look at that. Any clarifications needed? I'm going to have you guys try one right after this. What's the same as what you used to do? What's new compared to what you used to do? That kind of thing. Thinking about. A lot of this is very similar to Algebra 1 with just a little change. So one can argue if you had to label everything, what part of this is Algebra 1, what part of this is Algebra 2, you could say everything is Algebra 1 except right there. The fact that we take out I squared and put in a -1, that's the new part. Everything else we just did, combining the middle, how to FOIL, Fox method. And we could also say, well, your answer is written with the real part and then the imaginary part. That's kind of middle. Before the variable is always first, now that the letter is not first. So, but, you know, convince yourself, like, yeah, I know this. It's not exactly the same, but I know this. I've done it before. All right, so let's give you guys a chance to get involved. Go ahead and write this down. Let's do 3i and plus, no, not back up. Remember the imaginary comes after. So 3 plus 3i multiplied by, let's say, 2 minus 2i. Go ahead and give that a shot. You can either use the box or FOIL. I'm going to use the box myself. I'm going to set it up, and I'm going to let you guys try it out. See what you get. Compare with somebody next to you. See what they get, and see what you say. Choose either method that you want. First, we have 2 times 3. 6. We have 3 times -2i. Negative 6i. 2 times 3i. Positive 6i. And -2 times positive 3 is -6. I times I. I squared. Now you can see the inside and the outside seem to cancel out and equal 0. Positive 6i and -6i. So we're left with just, right up here, 6 minus 6i squared. However, I squared equals -1. So we get 6 plus 6. -6 times -1. So your final answer is 12. So you see how it's possible to add, subtract, multiply with imaginaries, and our answers can just come out to a real number. So if it happens and when it happens, it's not necessarily you did something wrong. Like what happened with my imaginaries? It must be there. It can cancel out, just like a variable can cancel out. Try another, or do you think you're good? Good, we're all right. So go back to where you're doing here. So we can add, subtract, and now multiply. So our next step is the and the division right here. Okay, let's try this out. 4 over 5 plus 3i. 4 over 5 plus 3i. Now, here's something first to identify. On the last problems, the adding, subtracting, multiplying, it's pretty obvious what you need to do. You need to add these together, you need to multiply these together, use the box, use the FOIL, or subtract. But looking at that, what are you supposed to do? What do you divide by? So it's kind of like, well, what is the actual question they're trying to get at here? What's wrong with this that something needs to be done? Because otherwise, it looks like it's a simplified fraction. It's not like we can reduce 4, 5, or 3 or anything. It looks like it's done. So it's one of those things like, I don't even know what I'm supposed to do or how am I supposed to start. So let me compare it to something you did in the past. It's the same idea as this. Looking at this, we should know that this is not a complete answer because there is a radical in the denominator. It's the same issue we're having over here. The whole reason this is an issue is that there's an imaginary in the denominator. So just like before, we didn't want to have a radical denominator. On these, we don't want an imaginary denominator. Right here, the way we got rid of the radical was to multiply it by itself. When you multiply the radical by itself, top and bottom, we top and bottom. On the bottom, rad 3 times rad 3 equals 3. No more radical. And on the top, yeah, we have a radical, but we don't care that there's a radical on top. The idea was that we started with a radical on the bottom, and now we don't have one, we're good to go. So we want to do the same thing over here. We want to multiply this by something such that after we multiply them together, we don't have an imaginary number anymore. So the question is, what can I multiply this by so that the imaginaries cancel out? And you can try to solve that on what we just did. Find it again. There we go. Kind of saw it on what we just did right here, where yeah, imaginaries can cancel out in the middle. How can we make this happen every time and not have to guess and check so that we can just get an answer that comes out to a regular old number? So that's the goal. So let me give you the method. Like we used to multiply it by itself on these, here's what we're going to do. We're going to multiply it by something called the conjugate. And it's simply this. Look at the sign in the middle and do the opposite. Change it. So we have plus 3i, we're going to change it to minus 3i. That's the conjugate. If we multiply this by the conjugate, you'll end up with, in the middle, canceling out with the i's, and you'll have no imaginary part. So before we go on back to the problem, let's just practice. What's the conjugate of 2 plus 3i? Minus 3i. What's the conjugate of about 5 minus 3i? Plus 3i. And what about negative 2 plus 4i? What is it again? Negative 2 minus 1. So notice how I don't care about the sign up here. It doesn't change. It's a minus 2 minus 2. It's just changing that middle sign. So going back here, our conjugate is going to be 5 minus 3i. Minus. Go ahead and multiply the bottom, see what you get. Again, box or foil. Five times 5?
20.
5 times negative 3i?
Negative 15.
5 times positive 3i. And that's what we're going for. Positive and a negative of the same number so that they will cancel out. Now I don't have an imaginary part in my answer. Negative 3 times positive 3.
Negative 9 squared.
And then I times I. I squared. Now, as you guys already jumped to, I squared is negative 1. So really in this box we end up with what number? Positive 9. So we have a positive 9, a positive 25, and then the imaginary parts canceling out. So my new denominator is just what? 34. So we have, on the top, doesn't matter, just multiply, distribute it out. 4 times 5 is 20. 4 times, yeah. And then just like we did before, check for reducing. Can this be reduced? Can we divide something to 20, 12, and 34? 2. Yeah, 2. So reduce this just like we did when this was plus or minus in the quadratic formula. Reduce everything by 2. And this is one of those things on that, for those redos, when we got redos, some of you just needed to do this. You got to this point, but you didn't reduce everything. So divide everything by 2. All the real parts by 2. We get 10 minus 6i over 17. These by far are the more lengthy problems on your homework. It'll take a little bit of time. And just like those quadratic formula questions, we miss up one little thing, like right here, if I said this was minus 9, then yeah, everything will be wrong. So careful to detail, organize your paper. The big picture is that the conjugate, that's what this is called, conjugate. If we multiply an imaginary number by its conjugate, come out with just a real number, we'll have the imaginary parts cancel out in the multiplication. And again, it's very similar to the rationalizing the denominator, take the radical denominator, multiply by itself. So that is that number from the homework. We'll look at a few others. Anything else that jumps out? Again, don't be shy about these. They're actually not too bad. And just write out all the work. Don't skip any steps. On 61, what's the conjugate on 61? And on 64, what's the conjugate? Root 3, yeah. And these are not more difficult because they have a radical here. Just remember when you multiply rad 3 times rad 3, this equals 3. Yeah, that's as far as being different or harder. That's all it is. Yeah. Cancel these out? No. No. Not cancel these out. Again, that's something you would do if it was a multiplying dividing. It does not work with adding subtraction. It does not work when you're adding subtraction. If this is just 5i root 3, and yes, definitely. Subtracting doesn't want you to do that. Real fast, right here. What is 10 plus I squared? Little review. Okay. 100 plus. So, once again, do two negatives make a positive? Do two negatives make a positive? You sure? If you're multiplying. What if you're adding? Two negatives make a negative. So one of those common things is that people get this rule in their head, or a rule in their head, and they want to use it on everything. So even if two negatives make a positive only when you're multiplying and dividing, they want to start doing it on everything. Adding, subtracting, multiplying, dividing, two negatives make it a positive, and it messes up half the problems you work on. This is another one of those circumstances. If you had 10i and you square it, yes, it is 10 squared and I squared when it's being multiplied. It does not work on addition. This means here 10 plus I times 10 plus I. And then you end up with 100 plus 10i plus 10i plus I squared. So when you have tools and you're given tools, you have to know when to use them. Not just use them always on everything. Two negatives make, if somebody asks you, do two negatives make a positive? You need to come back with, if you're multiplying and dividing. You need to know exactly when to use the tool, not just, yeah, it's true, I do it all the time. It's fun. Same thing over here. You cannot just say, well, it's pretty much the same, this is just multiplying, that's adding, I can still do. No, you gotta know when to use it. There is a line. Okay, there is a line. There are a lot of rules that work for multiplying and dividing that don't work for adding subtraction. Okay, so be very careful. This will come out to 99 plus 20i. Very different. All right, good luck. See you in the morning. If you have any questions.
No, he didn't take it. No,